Hello, good morning, and welcome to the course on Electronic System Design. I am L. Sarala, working as an assistant professor in the Department of ECE at Velagapudi Ramakrishna Siddhartha School of Engineering, Sahe, as it deemed to be university. With experience in teaching core electronic subjects, I am pleased to take you through this course that focuses on the structured design of electronic systems used in various real-time applications. This course will cover essential concepts such as system-level design, hardware-software integration, and practical aspects of developing reliable and efficient electronic solutions. I look forward to sharing practical knowledge also, designing approaches, and real-world insights as we progress through the sessions. So, so what are the contents in my course is the contents are product life cycle, design process, system architecture. In the system architecture, we will see how to design a electronic system for different type of products. Then system protection, reliability basics, component failures, reliability modeling, and electromagnetic coupling, grounding techniques, and ESD protection. And you will see the practical knowledge based on the real world insights through the examples. Okay. So before going to start the subject, first of all, I want to tell you what is an electronic system design. So electronic system design is a multidisciplinary field within electrical and electrical engineering that focuses on the design and development of complex electronic devices such as smartphones, embedded systems, and computers. The course also introduced the key challenges and methodologies used to build efficient, reliable, and scalable electronic systems. So this course also covers critical aspects, including the product life cycle, system architecture, protection requirements, and what are the different protection techniques, reliability analysis, and electromagnetic compatibility, and what are the different grounding types and shielding mechanisms. Okay. So there's also a major advantages in the technology that increasing multidisciplinary nature of the development process also, and the use of electronic devices in all aspects of our daily lives. It poses to immense challenges for every design engineer. So the ESD is a very important for every engineer who is working or who is going to working in a core domain industries. In that, how to plan for the design, how to develop. If there is any modifications in the design process also, we are able to move to the next step. So that's why we need to know what are the precautions before you are going to design any electronic devices. That is very important and a challenge for the engineers also. So this course will give a basic idea and also want to gain some knowledge to design electronic systems. So we will see the first topic, that is life cycle of electronic product. Okay, so it is a central concept in electronic system design to understand the product life cycle. So this design begins from the conceptualization of a product and continues through design, development, marketing, usage, and final disposal also. For example, it is important to recognize that nearly 50% of The sales in many technology companies come from the products less than 5 years old, right? Hence, understanding the life cycle of a product is essential to maintain the competitive edge and deliver consistent innovation also. Okay, so we will see one figure. So this is the figure will show the life cycle of any product. Okay, so based on the product, the life cycle may be vary. Here also we need to see the different stages of product life. Also known the product life cycle typically consists of development and disposal. So here development represents the development stage and disposal represents the marketing stage. Okay. So there are various steps in the development stages that are product planning, design and development. Then after development, the product will be run through the market. Okay. So with some uh, suitable prototype, what we have built inside that. And also we have some series of pilots. So this is the figure that will show the product life cycle. So first we will see the development stage. In the development stage of any product, if we want to design any product, first we have to plan for the product, right? So planning is very important for every engineer. Then at planning stage, we are not get any sale, we are not get any profit, right? So it is zero almost. Then after design and development stage, we have to spend some amount of money and cost that is represented by the curve here. So this is the curve we can represent it is a cost. Next, then we are in the stage of production. So in the production also the graph is somewhat high, right? Here we are spending some amount of money. Here we are not getting any profit. We are not getting any loss. We are not getting any sale also. Then once the production stage is completed, then we will roll out into the market. Then we will roll out into the market, right? So once the product is reached into the market, then sale will start, right? So from here onwards, the product in the marketing stage. So first one is the growth, then maturity, saturation, and then follows decline. In market stage, we will observe that the product once enters the market with high growth rates, but this eventually shows down as the product matures and market competition increases. The saturation stage is also represented here. So we'll see this is the saturation stage. Okay. Saturation stage. So in the saturation stage is marketed by stagnant growth, where competitive pressure intensifies and profit margin shrinks. As the product enters the decline phase, companies face the challenge of maintaining profitability, which often involves reducing direct costs and relieving product pricing strategies. So if you want to design any electronic system, also requires robust architecture plan. So this includes determining how subsystem interact and selecting appropriate components and ensuring reliability. Okay, so reliability is also an important factor for every engineer who is involved and understand the component. So, and it also understand the failure rates of the component and modeling system performance over a time. So what are the techniques? Just we have used in the protection for the any product that are electromagnetic compatibility and electrostatics discharge are applied to ensure the electronic system design can operate reliability in the real world environment. Okay, so that is very important for every engineer. Okay, every engineer should be careful about this. I hope you are understanding the life cycle of a product, right? In different stages of their life. Suppose, for example, direct costs are down by increased productivity. Then the relation between sale price and direct price is also increasingly reduced. So during a period of decline, the product is typically forced from the market by the competition or by other substitution products. So once if you are design any product, then automatically with another features, uh, another features of product will be entering into the market, right? So it is not a easy task if you want to survey with your product. For examples, I want to tell you some examples of life cycle of a product. Okay, so here I want to tell you some examples of these products. For example, I am considering a smartphone. So the product starts with concept development based on market demand. For example, I am considering a phone with a camera. So engineers then start planning the system architecture, deciding on the processors, memory, sensors, and display. Okay. So during development, multiple prototypes are built, right? And tested for performances, thermal management, and signal integrity to ensure the reliability. And also, we have to provide the protection for USB cables and charging ports. While EM shielding is used around the CPU, electromagnetic shielding also uh, shielding for to prevent the CPU from the interferences. As the phone enters the market, software updates and user feedback shape its success through the market and maturity stages. Eventually, the model is phased out, right, and replaced by a newer generation, completing the product life cycle. So this is also one easy task because we are in the development. We are already known about the mobiles. So here I'm considering the another example, that is smart integration controller used in agriculture. So this is also one type of product. So this will help you to control the irrigation. It will be helpful for the farms. Here the design begin with identifying the requirements, monitoring soil moisture levels, automating valve control, and sending data to remote server. Okay, so these are the main tasks. So then engineers choose a low power microcontroller here. Integrate moisture sensor and design a communication module like LoRa or GSM for a remote data transmissions. Here the prototype, what prototype we are used to get tested in different weather conditions to ensure reliability. So since the system operates in an outdoor environment, protection techniques like waterproof enclosures, surge protection, and proper grounding are crucial. So once the prototype proves successfully, the device enters the production phase, right? As farmers provide feedback and newer versions are released with better connectivity or AI-based irrigation algorithms. So the product progress through life cycle strategies. So in this summary of my first topic, not only about building functional electronic, but also about strategic planning throughout the product life cycle and throughout the product lifespan also. So ensuring protection from environmental and electrical threats and maintaining reliability. So these are all the considerations we need to consider when you are designing or when your product lifespan is increased. So with this increasing complexity and integration of electronic products in daily life, mastering this domain is essential for aspiring engineers, but also about strategic planning throughout the product's lifespan, ensuring protection from environmental and electrical threats, and maintaining reliability. With the increasing complexity and integration of electronic products in daily life, mastering this domain is essential for aspiring engineers. So, so it is important for everyone, not only for the students who are going to work, who are going to design any product during their studies or their research. It is very important to know about how our market, how our product will be uh, not be competitive about other products. That is not a small issue to let uh, their decline stages. You have to understand how why my product is going to be declined. That is also very important concept. Thank you. And we will see the next topic, that is the design process, in the coming lectures. Thank you.